The people who I call the biologically enlightened, who understand where all of this came from, 4.6 billion years of molecular evolution or biological evolution, we're this kind of inside club who get it and see what's going on. And I think once you're in that inside club, it's just the most mind-blowing thing.
Hey, Rem, how are you?
I'm fine. As everyone's listening to this, I am in Copenhagen. I'm really happy to be here. What a fun time. Can't wait to share what I've learned, who I meet when in the next episode. But we're here. How are you doing? How's Brooklyn? You holding it down?
Yeah, I'm holding it down. It's that terrible spring weather where it's 40 degrees 1 minute and then it's 70 the next, and you don't really know what to wear. But why'd you go to Copenhagen? You went last year. What's the draw?
We love going to Copenhagen because A, it's beautiful. If you've ever been, it's gorgeous. It's well kept. It has delicious food, beautiful sights. It's nice and central. So we'll be going to Sweden. I'm just going with my family. But then while I'm here, I'm going to visit some friends, hopefully some of our biotech friends at Carlsberg, which they have a great biotech and chemistry R&D facility that's been there for ages. Carlsberg's biotech team back in the day created the pH scale. If you didn't know that, they're the ones who started it as they were learning how to ferment beer. They're like, these microbes are doing something. And then meeting with friends from Novo Holdings, friends from Exozymes, and people in biotech. A lot is happening in Copenhagen, as you know. So I like to be in the scene and see what's going on in a different part of the world.
Sounds like fun. I've never been to that part of Europe. I'm looking forward to going one of these days. It sounds like a lot of fun.
Yes, I will squire you about town at that point.
Okay. So last week, the internet was flooded with Studio Ghibli images because ChatGPT added that as a feature. And then we were having conversations with people and they're like, have you asked ChatGPT to roast you? So we did that and we thought we would read each other's roast before we get into today's episode. So Erum, go ahead, roast me a la ChatGPT.
Okay, are you ready for this? Remember,
I think I am.
It's not me, okay? This is not me, so don't shoot the messenger. Okay, so, Karl, you bike commute, speak 5 languages, and have strong opinions about exponential tech. Yet you still haven't monetized your podcast that's more informative than 90% of conference keynotes. What are you waiting for? A protein folding algorithm to whisper a sponsorship deal in your ear?
Yeah, that's very funny, and it's almost totally accurate. For those of you who've listened to the podcast, you do know that we are being sponsored by the SynBioBeta conference, but all the rest of that is pretty accurate. So we have monetized the podcast a little bit, or we're starting to.
All right.
So
go easy on me.
Again, don't shoot the messenger. This is ChatGPT talking. Erum, you're strategic, smart, and ambitious, but let's be real. You've probably described a CRISPR startup as disruptive more times than CRISPR has disrupted anything. And let's not forget your podcast, Grow Everything. Buddy, that sounds like you're selling miracle fertilizer on late night TV. Grow everything, including your audience, hopefully. Also, you're trying to make Messaging Lab the most sought after consultancy in biotech. Bold, but when you say Messaging Lab, half of the VCs think it's an AI startup trying to replace therapists.
Oh, snap!
Very funny.
Oh, man. Wow. So harsh.
Yeah.
Now I know how ChatGPT really feels about me.
Yeah, we don't talk about CRISPR very much. You must be asking CRISPR-related questions a lot.
Oh, yeah.
ChatGPT.
There's stuff going on behind the scenes, Karl.
Yeah, I'm sure there is. All right. We talked about Common Side Effects, which I still haven't watched. You watched the season finale. What was your take?
Oh, my God. This is an incredible piece of television. Mike Judge has outdone himself again. Everyone has to watch this if they're in biotech, just in terms of the commentary around how the pharmaceutical industry operates, what's out in the world in terms of healing humans. And if you discover something, how do you get it into the hands of people? Different interests competing against each other. And then the drama. I forgot that I was watching an animated series. I think that's what really makes a lot of anime and this format of animation when it comes to adult themes really enticing, because when it's done right, you don't realize you're watching an animation. It feels like you're dreaming or something. And I was blown away by that season finale. It gave me season finale of Breaking Bad vibes. It was that
Wow.
like, holy smokes. If you're listening, please watch it and just please reach out and say you watched it. I mean, I did that solid for Mike Judge. I'm doing it. We're promoting it. No, we have not monetized that. So this is just a free promo for common side effects, but highly recommend it.
Right. And then you also put in this news that I saw yesterday, but I actually didn't add it, about the de-extincted direwolf. And you had posted on LinkedIn something like Game of Thrones vibes.
Yeah. I just saw it. Wow. Full disclosure, clearly we record these commentaries in advance. So recording this just as Ben Lamb, who is a co-founder, CEO of Colossal Biosciences, he posted a Time magazine cover of, looks like a wolf. I don't know what a dire wolf looks like. If Game of Thrones is accurate, they are much bigger wolves than what was on Time magazine. But at first I was like, wow, that's so cool. And then I was looking at other people posting about it. And our friend Matt DeLeo, who is a listener of the pod, we got to meet him at SynBioBeta. He posted, he's like, you know what? This isn't a fully de-extincted dire wolf. They gene edited a wolf to have some characteristic, which I don't know what genes were selected for. Was it for fluffier hair around the head? Or I don't know what it was. We had to look into it. But then I started reading other comments. This isn't really de-extinction. It's just changing the traits of a wolf that already exists. So there's greenwashing, where people say things are more sustainable than they actually are. And we say there's biowashing, where people put biotech into things that aren't really biotech. This is biotech, but is this de-extinction washing? Is it really truly de-extincting it or not? I think it's interesting. I like the fact that people are talking about it, and that's really the end goal for us, to have people talk about biotech in the mainstream, think about it critically, and here we go. This is a topic of conversation. What did you think?
Yeah, I can't find the news piece from Revive and Restore, but I would remind our listeners that we had interviewed Ben Novak of Revive and Restore sometime last year, and he talked about their conservation efforts, and they've also been talking about bringing back the passenger pigeon. We were at a biotech dinner in New York a couple of weeks ago, and we were talking to Chris Mason, who's also been on the podcast. And Chris is an advisor to Ben and the team at Colossal. And he said there was some exciting news that was going to come out in the next few months. So hopefully that's the beginning of the news. As we have noted, Colossal has raised a ton of money. Their valuation is astronomical, not tech or AI astronomical, but very high for a biotech company. And to deserve that kind of valuation means that there's a lot going on. And so I'm really looking forward to seeing some of the technologies that they release. But I think it's very exciting.
So I was also going to say, I'm also curious as to why they selected the direwolf. Was it low-hanging fruit when they looked at what genes need to be edited? They're like, okay, of all of the different animals to bring, this would be the easiest one? Or is there a certain reason? We know that they had specific reasons for bringing back the woolly mammoth and how it could help support the ecosystem. So there was a reason behind the woolly mammoth. I wonder what the reason is for bringing back the direwolf. So maybe we can get Ben Lamb on the podcast or someone else from Colossal to speak to why the direwolf, what's on the roadmap, why they made those selections, and what do they think about lightly editing versus full-on, not resurrection. I mean, is that what this is? I mean, no, it's not.
So I'm going to make a prediction that's going to lead into the next story that I flagged, because I think we've probably mentioned this in the past, that if you have a human therapeutic, but you apply it to the animal market, you're more likely to get approval, or you're able to get approval a lot faster. And so I wonder if there's some medical condition associated with dogs that lent itself to this de-extinction effort, and that's what we're going to see. I was going to point out was a story about the laptop repair market in New Delhi, where these people are basically creating Frankenstein laptops, but taking parts. These guys are taking what we would consider e-waste, and they're putting together these pretty powerful laptops at a price of $100. So people who normally wouldn't be able to afford a laptop, people who are going to school who really need a laptop, suddenly can go out, and these guys, they're pros at doing this, can put a laptop together. I'm not condoning this. I'm not saying that this is something that is necessarily allowed. I'm sure there's laws against doing this. I think it's fascinating. And it's the kind of story that I flag because I always think about what's it going to look like when it's the Delhi biotech repair market, or the African download gene sequence market, because that's the world we're going to move into.
It sounds like the storyline of Autonomous.
Yeah, there you go. Yeah. And then you had mentioned you went to this party a couple weeks ago and you met someone who was talking about the Osmos video game. I remember that game from the early 2000s or pre-2010s. Is that about right?
Yeah, I think so. I need to check to see. I want to play it because the way it was described to me was that this video game, you're in the perspective of a cell. You have to move as if a cell moves. So you have to propel yourself through space. And to think about the perspective of being on the nanoscale and how physics works on the nanoscale, so fascinating. I want to play this game. I also flagged it because you and I have talked about we need to have more biotech video games. In a way, AlphaFold was a game and it gamified the folding of proteins. What's next? Let's see if this Osmos video game we'll put in the show notes is still there. Is it being updated? If not, can we dust it off and resurrect it? I'm bringing that word back. I just love the word resurrect for some reason.
We are getting close to Easter, Erum.
Oh, that's probably, okay, that's what's happening. That's what's happening. But I'm just so interested in video games that educate. My son is really into learning math and spelling and reading on games. There's these great educational games that are fun, but I would love for him to play a biology game. He's starting to get interested. I got him this really cool kids microscope. So as we travel about Copenhagen, we'll be going to Iceland next. We're going to have the microscope. What are we going to see? What kind of bugs, plants? How small can we see? I mean, I got this microscope for like $30 on Amazon. I don't think we're going to see anything on the microbial level. I don't know.
Right. Yeah.
But hey, it's still a window into the microcosmos. And I think we need to have more fun things for more people, not even just kids, but people that are professionals or artists that want to be able to learn in a way that's not rote learning or just asking AI. Because yes, you can read things, but are you really retaining that information that you're reading? Or if you're watching things, but if you're engaging, that I think is going to be very exciting. So we're on the lookout for biotech video games. If you know of any, let us know. If you're working on some, hello, we're going to get you on the pod. So that's your fast track to be on the Grow Everything podcast if you're working on a video game that's biotech related.
Yeah, Erum, that's a perfect segue into our guest today. It's our first 3-time guest, John Cumbers, PhD, founder of SynBioBeta. SynBioBeta is a podcast sponsor right now. SynBioBeta conference is coming up in a month. I've known John for about 10 years. You've quickly become friends with him over the past few years. I think he probably, to a lot of people in this audience, he doesn't need an introduction, but John is probably one of the most connected people in biotech. What do you want to say about John before we get started, Erum?
Oh my God. John is an incredible person. I mean, when you're around him, he kind of just floats a little bit above ground, you know, like
in a good way.
In a good way. Yeah, in a good way, because he has to. He sees the future. He knows what's possible. He sees people doing things. He's able to synthesize and he's able to communicate both in a technical way and a friendly way. And in many ways that will intrigue our audience. And he has been intriguing audiences for decades. You and John have co-authored What's Your Bio Strategy? So you guys have worked together and created this amazing book for people to learn about how to biologize their business. So it's incredible to be working with John. And you guys will hear us have a great conversation on today's episode.
All right, let's let John take it away.
Today's podcast is sponsored by SynBioBeta. If you're a Grow Everything listener, you know that biology is the most important technology of the century. You also know that we're huge fans of the SynBioBeta conference. I've been attending since 2014, and it's my favorite conference of the year. There's no faster way to get up to speed on synthetic biology and its impact across industries. This year, we're going to be joined by inventor Dean Kamen, futurist legend Peter Diamandis, and Brian Johnson, among many others. SynBioBeta is where biology meets opportunities. So I hope you'll join us in San Jose, May 5th through May 8th to see how biology is transforming every industry. To get $400 off, use the promo code GROWEVERYTHING when you register at SynBioBeta.com. I hope to see you there.
John Cumbers, welcome back to the Grow Everything podcast. This is your third time here. It's a three-peat. Welcome back.
Thank you so much, Erum. It's so good to be here.
Yay.
Oh, wow. John, first person, three-peat.
It should be John.
Yeah, it should be John.
Well, I love you guys, and I think you're doing a great job, so I'm happy to come back and support the podcast, so thank you.
No, thank you.
Awesome.
All right. Well, to us, you're Mr. Synthetic Biology, and you have SynBioBeta conference. We are big fans. We attend every year. We participate. We love it. You have described synthetic biology as having the potential to be the defining technology of the 21st century. So, can you tell us a little bit more about what your personal philosophies are or life experiences that shape this philosophy?
I got into biology 25 years ago or so, and I was a computer scientist, and I had studied computer science for my undergrad, and then I went to do a master's in bioinformatics at the University of Edinburgh. And when I turned up at the University of Edinburgh, I didn't have a clue what was going on. I didn't know what a gene was. I didn't know what a protein was. I had studied high school biology, but not very studiously. So pretty much I was starting from scratch. I was 21 years old, and I went down to the basics of what is a gene, what is a protein, what's going on inside of a cell, all 30 trillion cells inside of the body, all 20,000 genes and all 100,000 proteins. And the enormity and complexity of biology is overwhelming still to everybody today. But the most amazing thing is what's going on inside of that cell. The central dogma of genes being read by these machines, polymerases, converted into RNA, RNA being read by ribosomes, and ribosomes translating these sequences into proteins. And there's all sorts of additions now to the central dogma and reverse transcriptase and things like that. But in general, the magic that's going on inside of a cell was opened up to me and laid out. I think the people who I call the biologically enlightened, who understand where all of this came from, 4.6 billion years of molecular evolution or biological evolution, we're this kind of inside club who get it and see what's going on. And I think once you're in that inside club, it's just the most mind-blowing thing that life is what it is, that a cell does what it does, that we have evolved to do what we do and be what we are. So that's just all natural biology. If you now take that to the realm of synthetic biology, the vision is that we can now program the DNA to do whatever we want to do, whether that's to grow an acorn that could grow into a house, or whether that's to engineer an antibody that's going to be a personalized cancer therapeutic, or whether that's to create a new superfood that's going to taste like nothing you've ever tasted before. The future potential of bits and converting into atoms and us being able to engineer on the atomic scale is going to be, as I said, the technology to define the 21st century. And this is why I'm so excited about biology.
So awesome. I mean, as you know, so are we. Otherwise, we wouldn't be doing Grow Everything. One of the things I love about you, John, and have known about you forever is that you're really good about creating community. And you've created this incredible community called SynBioBeta, and you've connected biologists and technologists. Normally, you would think these people would clash, and yet in your community, they work really well. And over the last couple of years, we've really seen the enormous impact that AI is going to have on biotech, on biology, on synthetic biology. But it seems like these are such different worlds, tech and biology. What have you learned, or what insights have you gained of putting these people together? Because they think differently.
I think that my background in computer science coming into biology and that enlightenment, that period that I had, has enabled me to translate between the two communities. When we first started SynBioBeta in 2012, the very first event we did, I invited a bunch of investors to come. And I didn't really know that much about investing at the time or investors. So I just picked some people randomly and said, hey, do you want to be on a panel? And at the end of the conference, somebody asked me, what is SynBioBeta? And I said, I don't know. I'm just bringing interesting people together and letting them meet each other. What do you want it to be? What do you need? And they said, more funding. They said the investors that you had on the stage didn't have any money and were talking down about the industry. You need to beef up the investors at next year's event. So I said, okay. We did two things to beef up the investors. We organized a very fancy cruise around the Bay Area, and we invited all the investors that we knew to come because I thought, well, investors are rich people like fancy boat rides. Let's invite them to come. None of the investors came on the fancy boat ride. All of my friends did, all of the founders and all the CEOs did, and we had an amazing boat ride. It was a huge amount of fun. Didn't achieve the objective that we set out to achieve, but did build a lot of community. The second thing that we did, which was much more of a success, was to create a course. And the course was called Synthetic Biology for Computer Programmers. And we taught that course at a number of venture funds around the Bay Area, including Founders Fund, which is Peter Thiel's fund, Innovation Endeavors, which is Eric Schmidt's fund, and a number of other venture funds. We ended up educating the tech investors about biology, about the central dogma, about what is DNA, what's a protein. It was incredibly successful. Founders Fund ended up investing in a number of companies, including Bolt Threads. Innovation Endeavors ended up investing in a whole number of companies, including Zymergen. And we'll talk about some of the successes and failures of the industry later on, I'm sure. But in that regard, it was successful in educating tech money to pay attention and get excited about biology.
That's amazing. Yeah, I love that story of the past. And I mean, for me, I came to SynBioBeta about 4 years ago. I actually attended. So just to hear a little bit of this history and how it has evolved is really exciting to hear. I've waited long enough. I mean, I'm really excited to talk about space. And that's something that for the listeners, they know that it's my favorite topic, space biotech, space biomanufacturing. And you bring a lot to that. You have this experience at NASA, but would love to learn what's new, what's going on in Synbio and space exploration and potential off-world settlements.
We actually just had a call yesterday with the astronaut Tim Kopra, who spoke at SynBioBeta 2 years ago. And we just announced yesterday also that Kate Rubins is coming back to SynBioBeta.
Yes.
We love her.
She's the astronaut that sequenced DNA on the space station with George Church. Well, George wasn't there because George doesn't like to travel. But she's coming back to talk about what she's working on in terms of the intersection of biology and space technology. And then Tim Kopra is leading one of the initiatives for one of the private space stations that NASA is funding. And he's looking for partners that want to use low Earth orbit and a space station up there for biological research and biological experiments. So I think there's some interesting signs that biology is going to be an important player in the future of space. I mean, I've actually not recently, but I spoke to Elon Musk about this at SciFu a few years ago and said, what do you see as the role of biology in space? And we were talking about life support and the need for bio-based life support. And actually, when I was at NASA, and I was there for 7 years, I was working in the life support division. Particularly, we were looking at food production, we were looking at wastewater recycling, biomaterials production. But I think the ultimate vision for synthetic biology in space is this idea of being able to synthesize any organism to do whatever you want in real time, to adapt to the environment that you find when you're in space. So evolution has taken billions of years to adapt these organisms to particular environments. Well, we end up landing on Mars and needing to figure out how we can grow potatoes in the perchlorate soil. Well, we haven't got billions of years to evolve to those conditions. So let's use AI to design organisms. And I'm incredibly excited about the role of AI now in biology, in particular the EVO2 model, which was a partnership between NVIDIA and the Arc Institute, Patrick Hsu. We actually have Brian He from Stanford, who's a co-author of the EVO2 model. He's going to be giving a talk at SynBioBeta coming up. But now you can take in whole genomes as context windows for the AI models, and you can now design whole genomes as well. So the dream is alive in terms of the progress towards whole genome synthesis and whole genome design in synthetic biology. And that opens up then the beautiful opportunity to design organisms for any environment that you want to go, including space.
Do you think there's any low-hanging fruit that we should work on that are going to make getting into space or what's going to happen on these space stations happen faster? Mars is a close, distant dream, but the space stations might be faster.
I'm actually pretty excited about the humanoid robots first. I think that's the low-hanging fruit, a starship full of humanoid robots to figure it out. They can build a biolab. I mean, they can do everything, actually. They can do the synthetic biology. They can design the organisms. They can till the land, remove the perchlorate. So I think that's going to be where the big, exciting advance comes from. I think it's still going to be a while before we're wanting to take biology there. But now that I think of it, I guess I've got to update my mental model because these humanoid robots weren't on the horizon when I was at NASA. And so I always used to think that biology was going to be the last thing that you would take because you cannot rely on it. It's unreliable right now. It's not robust. I mean, in certain situations, biology is amazing at what it does, but would you want to be on a space station on Mars with algae food as your prime supply of food? Probably not. You'd probably feel more comfortable with frozen ready meals and relying on your contaminated culture of spirulina that's sitting on the side of the space station. But now with humanoid robots, if they can set up the growth chambers and the stir tanks and the bioreactors ahead of time and demonstrate, look at that, this system's been running 24/7 for 12 months now, and these humanoid robots have produced the spirulina bars. They're just waiting for you to unwrap and eat them. That's a different story.
Yeah, especially if the spirulina bars tasted a filet mignon or whatever. You talked about superfoods that taste delicious that we've never tasted before. So that in tandem with creating nutritious, lightweight food would be interesting. But I'm curious, why humanoid robots? Why not just robots that can be programmed to do the task? Why do they have to be in human form?
It's a good question. I'm just thinking of the Optimus robot from Tesla. That's the name of the humanoid robots that Tesla's producing. And then Elon, probably about a month ago, said the end of next year. I think he said the end of next year. His timelines always slip. But the end of next year, a Starship full of these Optimus robots, I think that's the name, are going to be landing on Mars. So that's happening. And that's going to be there way before a biological system would get there.
Interesting.
Yeah. So let's transition the conversation a little bit, because you're talking about humanoid robots and slow progress. And you have mentioned in the past that synthetic biology's progress has been slow. And we've seen fits and starts. I think of the alternate protein food space as being particularly challenged. And funding has been challenging, but yet the technology continues to advance at that exponential pace. But if you could remove one major bottleneck that would hinder the advancement of synthetic biology, what would it be and why?
Yeah, I'm not sure it's a bottleneck that I'd remove, because I think that the synthetic biology workflow of the design, build, test, learn, this loop that we go around, it's pretty successful. And it's been a great model that the industry's been following for a number of years. We get to a bottleneck at each part of the cycle. At one point, it was build. Synthesis of DNA was a problem. It used to cost $4 a base pair. Now it costs 10 cents a base pair. So the barrier has been reduced. Then it was test. Well, now we've got cheap DNA. We need now high throughput automation to be able to test it. And so we went from 96 well plates to 384 well plates to 1024 well plates. And high throughput testing, then microdroplets and microdropules and droplets and things like that. So we move with the automation equipment. And then it's design. Well, let's now go back to designing the genes and the genomes. And we've had drag and drop interfaces and combinatorial assembly languages for biology. And now, you have things like Evo2 and whole genome designs. So design is no longer a bottleneck. We're now going to have AI that can design a gazillion genomes. So maybe we're back to the build bottleneck now. And you're seeing new DNA synthesis companies come online like Elegant and Answer that are doing enzymatic DNA synthesis. Blue Ribbon Bio is another DNA synthesis company that's coming online. And they are competing with the incumbents like Twist and IDT and Thermo Fisher. So you're seeing innovation in that build. That's going to drop the price, increase the availability of whole genome synthesis, and then probably we'll be back at the test bottleneck. So I don't have any one in particular, but where's this going? Well, it's going to the rapid iteration of design, build, test, where I can actually program a bacterial genome on my desktop, hit print, boot it up in the lab, and run a test and see what it does, whether it produces the flavor of the filet mignon spirulina that I wanted or not. That's what we want to get to, where we can program biology as rapidly as we can program an iPhone.
Yeah, thanks so much for that. I mean, it really helps think about it in that process. So then in this case, what area of synthetic biology do you see as currently underfunded? Do you think that's DNA synthesis, or is there other parts of Synbio where if we gave you $10 million to put towards one area of synthetic biology, which probably isn't enough, but where area would you put it into?
I'd probably look at putting it into, I think about events and community. And so the community that I'd like to build is called Bigger Data for Biology.
Oh, wow.
Which brings people together, puts them in that design, build, test, learn loop, and then says, let's all take a giant leap together so that we're not getting at a bottleneck in a year about the next one and then the next one. Instead, let's lay out a 10-year horizon. Let's lay out a 10-year timeline of where we want to be. And let's all try to move together in lockstep to try to get there. And therefore, everybody's predicting and trying to see where the test people are going to be and where the build people are going to be. Because when you get those disparate groups in a room together, one of them will say something like, well, of course, we can't build a whole bacterial genome for less than $1 million. And then somebody else would say, why not? What's the bottleneck? And they'll say, well, the bottleneck is in the droplet size. And then somebody else will pipe up from the tech automation group and say, that's not a bottle size. We just made that up because we didn't know what droplet size to use. So we just put 10 picoliters. So you get the people talking to each other and laying out a framework and challenging their assumptions. So it's not a particular technology that I'd fund, but it's a community that wants to move towards programmable biology and wants to move there together in a pre-competitive phase so that we can have the whole industry walking in lockstep. I think that would be wonderful.
Yeah, I mean, it's just a little tease to what's to come at SynBioBeta, this bigger data for biology. Is this something that is currently being worked on? Sounds important.
It's something that I'm noodling on with a particular government agency that is also interested in these kinds of topics. But what we did launch this year at SynBioBeta is something called Hyperscale Bio, and that is our new AI bio community. And we have about 20 AI founders and CEOs and executives coming, both from the big pharma world. We have Kim Branson from GSK, who leads their machine learning. We have Andrew Phillips from Sanofi, who leads their AI drug discovery. And we have a whole ton of AI bio CEOs like Raphael Townsend from Atomic AI and Alexander Zangolini from Azeez, who's working on machine learning for enzyme design. We also have the CTO of Microsoft come in to talk about their investments in AI. That's Kevin Scott, and he's going to be doing a fireside chat with Drew Endy on AI and bio. So yeah, about a third of the conference is all about AI and bio this year, and that's a big area that I'm most excited about. We also have human biology, we have planetary biology, and we have tools and technology. So all the pieces are there. There's about 40 different breakout sessions going. So if you're interested in any one of those particular topics, like the design, the build, the test, or learn, you can find your tribe and connect with them there.
Yeah, I have to say that I'm super excited about the hyperscale sessions or that idea. I think I was a little slow at first I think, Erum, you can back this up. I was a little slow to embrace the AI wave. And yet now every day we're doing something. And I just see how it's transforming our thinking around biology.
I think you were very fast compared to a lot of other people.
Okay, well, thank you. I feel like I was really slow.
Now you talk to AI more than you talk to me. And we have a weekly podcast. So,
But I think everybody feels that way. Everybody is intimidated by it because I don't know about you. I don't understand the models. I don't understand what's going on under the hood. I'm using them as a consumer. I know it's a huge wave of innovation happening. But yeah, there's some really smart people working on some amazing different kinds of models that are feeding in different biological data and spitting out some amazing results. So you've got to try to keep up with it. But I think it is intimidating to most people. But that's why we've got so many of the people coming and doing breakout sessions. So there are technical sessions where you can go and meet with these people and they'll lay out the models and they'll talk about what they're doing. And there'll be some hands-on sessions where you can look at some of these tools and how to use them. I think it's natural to be intimidated by any new technology, but you've got to embrace it.
Yeah, last night I actually was loading a non-internet dependent version of Olama on one of my laptops so that I could start to play around with it without being dependent on the internet and see what would happen.
And does that not have any guardrails? Can you make a biological weapon with it?
Well, so here's the thing. The way you test it is you would install it as an administrator on a Windows or Linux or Mac laptop, and then you ask it how to steal a car, which is something I'm fascinated by for a lot of reasons, but we won't get into now. And
living in Brooklyn.
Listeners, I'm not stealing any cars. This is a hint for something that's going to come in the future. So it didn't give me the answer. I watched a guy on YouTube explain how to do it. So I must have done something wrong with the installation because it said, I'm not able to answer this question. But anyway, let's talk a little bit about emerging technology. We're talking about artificial intelligence, there's quantum computing. These things are impacting synthetic biology. What are the ways that we're not talking about those enough?
I'm not an expert on quantum computing. We talk quite a lot about AI and the impact that's going to have on the field. I am always looking at what's next and what's coming down the pipeline. So I'm curious on your take. What are you most excited about in terms of these technologies, and where do you see the intersection with synthetic biology?
I think Erum is more educated on the quantum side than I am. I'm still a doubter there, but as with AI, I'll probably become a quick evangelist for it once it becomes readily available. For me, what's exciting about AI and biology is just biology continues to be this black box, and AI will make it easier for us to teach people about it. It's going to make it easier for us to understand it. It's going to make it easier for us to engineer it. I think a lot of the things that we take for granted when it comes to biotech are really hard to do physically. And when you can solve those problems in silico on a computer with AI before you actually hit the lab, I think those kinds of things are going to move things a lot faster. And then when you combine that with design tools, I'm thinking specifically around material design, being able to design materials on an atomic level so that you are getting very specific performance characteristics that don't exist in nature. I'm super excited about that, as well as re-examining what the toolkit is that nature has given us. Where are the places like the ocean and all these trillions of microbes that we don't understand that all potentially have tools that will continue to advance our knowledge for engineering biology. So I'm excited about all that.
One area that we have represented at the conference this year is non-canonical amino acids. Have you been getting on that bandwagon?
No, not at all.
So there's a company called Constructive Bio out of Jason Chin's lab at the University of Cambridge. And they just raised, I think they just announced $76 million just this week. Jason is giving a keynote at the conference, and the CEO of Constructive Bio, Ola Wojcicki, she's going to be speaking as well. It's a really, really cool platform. So non-canonical amino acids are being used right now in these GLP-1 inhibitor weight loss drugs. The way that these weight loss drugs work is that they bind to GLP-1 and they prevent it from being degraded. GLP-1 is the molecule that tells your body and your brain that I'm full. So when it is degraded, it means that you're hungry. These GLP-1 inhibitors bind to GLP and prevent the molecule from degrading, so you stay hungry for longer. What the companies have done, the pharma companies that are making these inhibitors, is made these inhibitors with non-canonical amino acids, which are these non-natural amino acids that the body finds difficult to break down. So because the body finds it difficult to break these things down, they bind and stay around for longer, which means you stay full for longer. So it's a really cool innovation. Right now, these non-natural amino acids or non-canonical amino acids are a pain in the ass to manufacture because you need to synthesize the enzyme or the protein one amino acid at a time using chemistry. You can't synthesize it using biology. And this is where Constructive Bio comes in, because they have got a completely engineered genome. I think it's a yeast genome. And they've done the thing that George Church was doing in E. coli, which is to remove I think it's the amber stop codon. So they've edited the genome to take out one stop codon. So it's no longer a stop codon, but instead they're using it to insert a new amino acid into the protein that they're making. This is a big deal because you can now make these non-canonical amino acid-based drugs using fermentation. You don't need to make it using chemical synthesis. And so it means that the bottleneck and the expense of these GLP-1 inhibitors is vastly reduced because you can make them through fermentation instead of chemical synthesis. So it's going to be a really interesting talk, and it's going to be a really interesting future because it's not just these weight loss drugs. Once you add non-canonical amino acids, you have practically unlimited chemical diversity that you can make in these proteins. That's going to be huge for drug development. But it's also going to be huge for novel materials, which is one of the other applications that you said that you're excited about.
Yeah, I want to go back to this question because I think I want you to answer it. What are you excited about when it comes to emerging technologies like AI or quantum and their application to biotech? Because we talk about this stuff all the time. It's good to have John here because he's thinking about it from a different point of view. And I think I went off. I want you to go off a bit.
Well, I mean, I say like one of the things that you said, Karl, was that biology is a black box, but AI too is a black box. John, you mentioned that like, oh, I don't really understand it. A lot of the CTOs don't understand how the AI works as well when it comes to that black box and the hallucinations and why it does that.
That's a good point.
There's black boxes talking to black boxes. And I think that quantum can do something here. There's a lot happening around the corner. We need to have a quantum track at SynBioBeta. Livo Holdings has a quantum chip challenge or who's working on quantum. So when you have this type of computation, what can it tell you about biology? Because biology operates on quantum levels. When you think about photosynthesis, remember at SynBioBeta last year, the year before, Drew Barry creates these biological simulations that are very accurate. And then when he was showing the simulation, he put a placeholder for quantum effects. He's like, I don't know how to simulate this, but it was like this little light that was shining. He's like, I don't know how to simulate that. But if you have quantum computing, you could simulate that. So I think that's going to be really interesting to see how much more of understanding we'll have of biology and how much more we can do on a quantum level with biology. And what can that reveal? Will it reveal that we live in a simulation? I don't know. I mean,
we definitely live in a simulation.
But at least we can know we're evidence. We're these very smart monkeys. We want to be able to see things because we have eyes. Eyes are our confirmation. I mean, obviously we have other senses, but eyes are our main one. So we need to see the data and say, okay, yeah, it's true. We're in a simulation. But I think that's going to be really exciting when quantum comes on. And if you want to do a quantum track, holler at your girl, John, because I'm happy to do that.
So we had a session last year on quantum biology because there's a quantum DAO. I can't remember the entrepreneur's name. Her first name is Clarissa, I believe. Mm-hmm. She pinged us this year about quantum bio. So there might be a breakout on the session that's going to appear. As I said, we have about 40 breakout sessions. So I can't, unfortunately, keep track of them all anymore. But there might be a quantum session on the agenda already.
Yeah, I'll keep my eyes peeled for it. If they're having one, I'll be sure to go. Unless it's happening at the same time as Kate Rubins. Otherwise, yeah, that I won't be able to go. Cool. So we went deep, but let's go back up to our world of just living in society. And there's a lot of cultural change that really still needs to happen to get people thinking about biology and that it is core to everything. This podcast is called Grow Everything. How can people affect this cultural change within society? I know you've been working on some things to really bring Synbio and biology into the mainstream versus right now, SynBioBeta is really industry focused and bringing different professions into Synbio. But what about other people?
Yeah, it's been my dream for a long time to bring other people into this. I mentioned at the beginning of the show that I think 10% of people are biologically enlightened, that they get it. They're part of this inside club. I don't want that to be the case. I want it to be 100% of people are part of this club. It's no longer an inside club. So we started, I say me and my co-founder, Thatcher Mines, executive producer, we started an animation studio last year. It's called the Biological Enlightenment Studios. And the goal is to make a Pixar animation studios for biology. And Drew Barry is one of our advisors. He is the person that you mentioned who's making the biological animations. And since the last time we spoke about it, we've brought on a few other advisors as well. George Church is advising us, and also Galen Sussman, who is the producer of the Pixar movie Ratatouille.
Oh, wow.
We've really started to build up the credibility of the team and the advisory team. We've raised a pre-seed round, and we just put out a job posting yesterday looking to hire a writer. We're looking to hire a writer who has a biological mind. They're part of the biologically enlightened. Also, we've been applying for some production grants as well. And one of the grants we got 3 letters of support from 3 Nobel laureates as well. So we've really just been building up, the credibility of the organization and the team and doing some fundraising. And the goal is that by 2027, we'll be launching this 25-minute short called Lee's Lab, all around this little girl growing up in the Borneo jungle, trying to understand how it is that a firefly lights up at night. and talking about the bioluminescent enzyme luciferase and how it works and visualizing it as well.
Wow.
That's amazing. Congratulations on the progress. I love hearing that.
Yeah.
Thank you. It's exciting. Yeah, it's a labor of love, and I'm just so passionate about it.
Yeah, it's absolutely necessary, I will say.
Yeah, we all have kids of different ages. Mine are basically grown, and they've all been exposed to biology. Some like it, some do not. Erum teaches me something new every day about her kids.
Ooh, Lee's Lab. I love it.
Beautiful.
What a beautiful
Yeah.
animation. John's showing us the animation.
Yeah, this is the little girl, science fiction for curious kids.
Yeah, very cool.
Instruction. I love it.
It's designed for my kids as well, but by the time it comes out, they're probably going to be too old to appreciate it as a child. But like all good Pixar movies and Disney movies, it's the kids that watch it, but it's the parents that end up getting hooked and educated as well. So, yes, I'm pretty excited about that.
Yeah, I am too. So, John, it's hard to believe this, but it's been almost 8 years since we published What's Your Biostrategy?
Wow.
Let's talk about biostrategy for a minute. I was on a call the other day with a bunch of Rutgers consulting students who wanted to talk about biostrategy. And you introduced me to the idea, and we ended up writing this book together. Erum was one of the editors on the book. If you had to design a biostrategy for a more sustainable society, what would that look like? What would be key elements of that strategy?
One of the key elements would be distributed biological manufacturing. This idea that you don't have to have these giant centralized facilities with shipping and logistics for stuff. But instead, if you've got CO2 or if you've got corn and you have energy and water, then you can have a small scale fermentation plant that can produce whatever it is you want to produce. Think of it as a craft brewery. Every factory now is a craft brewery, but instead of brewing beer, it's brewing materials, or it's brewing pharmaceuticals, or it's brewing food products. That's, I think, at the core of a biostrategy. And it's interesting with all of these tariffs and Trump wanting to bring back manufacturing to America. Let's bring back biomanufacturing, or let's bring biomanufacturing, because as McKinsey says, 60% of global inputs can be made with biology. Let's rethink the biostrategy for the US economy. Think about local production and local distribution. That's, I think, at the core of what I think the globe should be doing around biomanufacturing. Why is it that I'm still throwing away my trash and into 3 different recycling bins, and they're being hauled off and in general not being recycled, at least not in a way that I think makes sense for all of that biomass and where it could go? So we just seem to have inefficient systems for physical goods and manufacturing. And I'd love to be able to close the loop on all of those.
Yeah. John, you are in a position of influence. You are speaking to all these other influencers that can spark change. And can we rally around a subsidy for biomanufacturing? Because a lot of what has helped industry in the United States has been government subsidies. Do you see any line of sight in that? I know right now we're in a world of flamethrowing and slashing and burning, but to rebuild, is that something that we can rally around? Do you think it can happen? Do you think it's necessary for us to build and subsidize biomanufacturing?
I'm sounding like a broken record every time I talk about this, because if we tax the thing that is causing air pollution, causing climate change, if we taxed CO2 being sucked up out of the ground and burnt in terms of oil and coal, if we put the real economic cost to the public of that pollution, then biology would be competitive already and it wouldn't need subsidies. So that's my wish, is that we don't need to subsidize. It can compete fairly. We've just fairly put the cost of pollution of CO2 into the equation. That would be where I think we need to go.
That would be nice.
Yeah.
I don't know in the next few years, but hopefully sooner.
It's definitely not happening in the next 4 years.
Yeah. Okay, so let me change the subject a little bit. We think a lot about unconventional ideas in biotech and synthetic biology, but what unconventional idea in SynBio excites you, but maybe is considered too radical or impractical based on current standards?
I'm definitely very excited about longevity again. I've been through a somewhat trough of disillusionment, thinking that just biology is too complicated, the brain is too complicated, we're never going to have radical life extension, which is the main reason I got into biology in the first place. I believe that humanity is going to be living forever at some point in the future. I just don't know what point it is. Let's rally around this in terms of trying to fund aging research and try to understand it so that we're the last generation to die. And recently I come across a number of entrepreneurs and thought leaders who have been talking about the idea of replacement. And I don't know if you've been following this or not. There was a book written by John Hibbert, who's now a program manager at ARPA-H, called The Replacement Theory of Aging. The replacement theory of aging says if you can replace your body bit by bit through cell therapies, then you should be able to live as long as you want. Particularly looking at the brain, John's research showed that you can inject new neuronal stem cells into the brain and you can have them integrate into the existing neural networks and show that they are functional, that signals can travel between the old neurons and the new neurons. He hasn't yet shown that you can replace the function, but there is precedent showing that neurons have plasticity. One example that he talks about from his research is a patient that had a tumor growing in their prefrontal cortex the size of an orange. And so it grew slowly over a few years, I think. And as it grew, the neurons around the tumor ended up replacing the function of the neurons that were eaten by the tumor. So the patient was still normal. They still had all of their normal functions. But when you look at them in an MRI, you could see that the functions that should be taking place here are now taking place on the periphery here. And so those neurons have demonstrated plasticity, be able to adapt around it. So what this indicates is, hey, yeah, if you can inject your own stem cells and now you can turn skin cells into neuronal stem cells, inject them into your brain, you can have a new set of neurons. So it's this idea of the ship of Theseus, which is this ancient myth that if you replace parts of the ship bit by bit, is it still the same ship? Now you can potentially do that with the human brain. And this isn't just science fiction. There's actually a company called Aspen Neuroscience. The founder of Aspen is a woman called Janine Loring. She's actually going to be speaking at SynBioBeta. And Aspen Neuroscience has a clinical trial for Parkinson's disease right now, early stage onset Parkinson's disease, where they are injecting neuronal stem cells into patients to replace damaged dopaminergic neurons that are not producing enough dopamine and causing the effects of Parkinson's. So that's already happening. I'm very excited about the idea of brain replacement. And then the second thing I'm excited about is the idea of body replacement and being able to grow a brainless clone of yourself so that you can have a replacement body. This also isn't science fiction. There's something called anencephaly, which is a horrible condition where an embryo develops without the cortex. Most of the time, the parents choose to abort the embryo and not bring it to term. But some people who are opposed to the idea of abortion, even though they know that this baby is growing without a cortex, they still want to bring it to term. So they have delivered these babies. Now, the really interesting thing is that despite this baby not having conscience, it has no brain. So therefore, there is no consciousness inside of it. But it has a brain stem. And it's the brain stem that controls growth and development, the core functions of breathing, food going through the system, and things like this. There are cases that people have been kept alive by families through development, through growth, through puberty, 40, 50-year-old bodies that have no brain inside of them. They even exercise them to keep the muscles from wasting away. This exists. So there's a few companies out there that are working on this kind of thing, which means that in theory, you could have a spare body. You could have a clone of yourself that's grown, no consciousness. So I think it removes a lot of the ethical considerations. Clearly, there's a lot that we should discuss, and it's illegal to clone a human in the US. But imagine that, having a brainless clone, and then it's an engineering problem to now do a transplant of your brain and spinal cord into the new body, which isn't an easy thing to do. But the reason I'm excited about it is because it's an engineering problem, not a scientific one. So I just think it's very, very exciting where that could go.
That's amazing.
Yeah, that's how you live forever. You just keep going to a new body. As long as,
Right.
and then you can replace your brain. I mean, I did hear your body naturally does replace its cells, except for the brain. It replaces cells every 7 years, the cycle of
Right.
cell death and cell birth. So looking at that system, it would be really interesting. That's exciting. So we're almost towards the end of our conversation, but we'll love to hear a little bit more about what's going on in SynBioBeta. Hyperscale, I'm very excited about that. What else? Get us excited about going to SynBio. I'm already excited because I have the inside intel.
Well, we have some really, talking about neuroscience, we have Max Hodak coming to speak. Ed Boyden is coming to speak. We have Kate Six from the Department of Defense. She's going to be coming to talk about the Department of Defense Biotech Initiative.
Oh, wow.
Dean Kamen from the Advanced Regenerative Manufacturing Institute is going to be giving one of the keynotes. And we have two important sessions on longevity that I didn't mention. One of them is with Brian Johnson, the guy who's measuring everything about himself, and Peter Diamandis as well, who wrote a new book, a guidebook on longevity. So I'm very excited about all of the sessions that we have and all of the keynotes that we have. It's just going to be the most interesting, eclectic event that we've ever done, as well as all the big pharma companies that are coming, talking about drug discovery and AI, all of the DNA synthesis companies that are coming, announcing their new innovations and new product launches. And then Pat Brown and Matthias Machnuk from Notco are going to be speaking about the future of food as well. So it's very diverse, very interesting mix of people all around planetary health, human health, and hyperscale bio.
Oh my gosh, I'm so excited for it. SynBioBeta this year starts May 5th, Cinco de Mayo. John, will you be singing with the mariachi band?
Maybe. We haven't decided what my musical performance yet will be, but that's always a good contender.
Yes, please, please. I cannot wait for that. That's what I'm most excited about. But just want to thank you so much for waking up at the crack of dawn to speak with us and tell us about SynBioBeta this year, your perspective, your experience. It's always a joy to have you on the Grow Everything podcast.
You're very welcome. So nice to chat with you, and I look forward to seeing you in a few weeks.
Excellent. Okay, toodaloo.
Thanks, everyone. Bye-bye.
Hi, a quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business. So Karl, what'd you think about that episode with John, our buddy, our pal?
I mean, like I said, first time we've had anybody on 3 times. We are going to have a couple of repeat guests coming up, but John always brings it. Like you said at the beginning, John's at the center of everything and everyone. I think in one of our earlier interviews with him, he said that one of his secret powers is bringing people together, that you could put him in a crowd and within a short period of time, he would be introducing people to each other. So he's very inspiring for that. And just the amount of knowledge that he had. I thought when he was talking about humanoid robots on Mars, that was super interesting. I really want to compare that to what Erica De-Extinction had to say. I'm more of a microbes first on Mars before robots, but we did send a robot first. So What did you think, Erum?
Yeah, I love the fact that he talked about the humanoid robots because that's a big question. And we talked about that on the episode. Do we need humanoid or can we have just robots that are designed for a specific task? I think that's a great conversation to continue having in the industry, thinking of what purpose will this humanoid robot serve? Or you're trying to have someone do things that we do and it could be anything. Maybe folding clothes requires more dexterity, so you just need to make hands. But then shouldn't they be robot hands? Do you need a head and a body? But anyway, that was really cool. John also talked about the central dogma. And I think it's really important for people that are not in biotech to understand what that is, to talk through the layers of abstraction. Because once you start looking at that, and there are videos on YouTube about the central dogma of biology, you start understanding what the biological stack looks like and where some people operate on the DNA level, some people operate on the cellular level, some people operate on the metabolic level. What does that mean? So we talk about these things, but to have a framework to organize your biological thinking, I think, is super important. And John always does talk about the central dogma as his foundation when he's being interviewed or when he's at a conference. And I wouldn't be surprised if he kicked off the SynBioBeta conference with that.
Yeah. At the beginning of the podcast, you talked about Osmos and more biotech in video games. You talked about common side effects. And John is doing this project, Lee's Lab, which is going to be a Pixar studio for biotech stories. I think that's headed in the right direction. I'm a big believer in that. I think it's really important. We say it all the time. We need more biotech entertainment.
Oh, yeah, absolutely. And I met a student of Elizabeth Hennaf's. Her name's Caroline Chow, and she created a play called Microbes, ! And I just love that she's bringing creativity to biology and getting people to start noticing and thinking and sparking curiosity, because once it's sparked, you can't put that back in the bottle. John was talking about the biological enlightened. So once you start thinking about it, you can't put that genie back in the bottle. It's going to be on your mind all the time. I studied biochemistry, but more towards the chemistry side. And then I worked in biotech, still towards the chemistry side. But then when I met you and the GenSpace community and a bunch of people and started really thinking about biology as a technology, just as a life force and how diverse and how much variety there is, you're like, wow, it's incredible. It's such a great way to think creatively. It's a great space. There's no shortage of storylines that you can generate from biology.
Yeah.
There's so much going on. There's so much dynamic happening between different organisms and different environments. So it's a great place to draw creative endeavors from.
Yeah, I completely agree. So John organizes the SynBioBeta conference. We're both going to go. Erum, what are you excited about at this year's conference?
I'm excited / a little nervous about my breakout panel discussion. The breakout panel discussion is called From Genes to Giants. And we have some amazing panelists. We have some earlier stage companies with amazing founders. Pratik from BioEgg, Jens from Insempra will be on the panel. And then we have two heavy hitters, Jose Carlos from Procter & Gamble and Aaron from Cargill. And we met recently, and our whole conversation is really going to be about how do innovators partner with these large companies? What are the frameworks that we can apply and people can apply to approach bigger companies or bigger companies to approach innovators? It's a two-way street. And how do we cut through the complexity? How do we navigate these organizations? How do we create deals? It's only a 45-minute panel discussion, so we're going to try to get through as much as we can. If you're coming to SynBioBeta, definitely check out our session. I'm really excited for it. But what about you? I mean, you're a veteran. You've been going to SynBioBeta since it first started when it was just a small gathering.
Yeah, I said it on the podcast. I'm super excited for this Hyperscale Bio, which is this idea of AI meets biology. I am running the consumer biotech track, and we always talk about consumer biotech and the developments that are happening. I'm also doing a panel with a couple of people that we know and then some new people. It's also going to be like, what does personal care and beauty look like in 2030, 2035, which is just a few short years away. So I think it'll be really interesting to speculate. And if you come up to me after the panel, I will give you a hug.
Okay.
And a sticker. We're trying to get stickers made.
Oh, yeah.
So,
That's the call to action. Come see us. We'll give you a sticker.
Yeah, I'm just excited to go. It's always exciting to go see our friends. We know a lot of people that are there, meet a lot of new people, find new people for the podcast so that our listeners can meet some of the people that we've met and to really hear what progress is being made at this intersection of biology and technology. It's an exciting place to be.
Yeah, absolutely. It's always fun to see John in his element. He's a master of ceremonies, and I really hope that this year he does do the mariachi singing. It was incredible when I saw it with my own eyes. He's really good. He really brings it. It's not like he's doing it as a karaoke thing. We all think we're good singers and we're not. He is really good. So hopefully he does that. I know he has a lot on his plate, but if you want to see if it happens, come to the conference and we'll all hang out.
All right. Well, I think that's the pod.
Yes, that's the pod.